This is mathematics, and we are here with the fourth section of algebraic expressions, which is negative and fractional indices. All right, so I have written the laws of negative and fractional indices before, so we can go through them more quickly. So guys, a to the power of 1 over m is root index m of a. So the thing is, if you have roots with an index, let's say n, and number under the radical, this is called the radical, and the number under the radical is a, you can write it in the index form as a to the power of 1 over m. Why? Because this power is 1. So the exponent of the number under the radical or radicand, let's say the number under the radical is called the radicand. The power, the exponent of the radicand is gonna be written as the numerator of the new index, and the index of the root is going to be written as the denominator of the new form. So I can write root index m of a as a to the power of 1 over m and vice versa. So I'm going to a to the power of, therefore from the first one we can conclude that the things that I explained. Root index m of a to the power of n is going to be equal to a to the power of n over n. So basically, based on whatever that I told you, this can be concluded. However, or we just basically went through this one. And the first law is coming from this expression, where n is 1. So it is just a derived formula. So the third law, a to the power of minus m is going to be equal to 1 over a to the power of m. Guys, very important. A minus in the power, in the exponent, does not change the sign of the number. Not at all. But it reciprocates, and we have the reciprocal of the base to the positive power. What do I mean? Okay, right. If you have, I was simply explaining this one. Okay, let's say you have a to the power of minus m, and this is simply 1 over a to the power of m. But if you have a to the power of m, you can also write this as 1 over a to the power of minus m. So if you are going to reciprocate an number, you just change this sign. You just change this sign of the power, and you put it in the denominator of a fraction that has a numerator 1. Or let's just not complicate ourselves. This is the rule, and you can use this rule whenever and wherever. A to the power of minus m is going to be equal to 1 over a to the power of m. And guys, any number, okay, let's say a is not equal to 0. Any number to the power of 0 is going to be equal to 1. This, it has no exception. Why do I say it has no exception? Because even 0 to the power of 0 is going to be equal to 1. But I said a is not equal to 1, is not equal to 0 because we're not dealing with 0 equal to 0 right now. But in general, because here you might think that, okay, 0 to the power of 0 can be 0 over 0, which can be undefined, which can be 0, and which can be 1. It can have 3 values, but just know that 0 to the power of 0 is going to be 1, and you do not need to worry about the proof at all. And it's not going to come in your exam as well. I'm just saying this as for your general knowledge. So any number to the power of 0 is going to be 1. Why? Because, okay, let's say that I have a to the power of 2 divided by a to the power of 2. From the first section, guys, laws of indices, we know that this is going to be equal to a to the power of 2 minus 2, or a to the power of 0. But I have a question, guys. Isn't any number divided by itself equal to 1? So a to the power of 0 is going to be equal to 1. So this is just a simple proof for the fourth law, and so you can get it much better. And I have written an example for you. This is not in the book, and we're gonna solve this together. If y is equal to 1 over 8 x to the power of 2 over 3, write 2x plus 5 in terms of y. I suppose this can be the hardest question that you will get for algebraic expressions. This question is just very hard. If you want, you can pause the video and try this question out. If we're gonna solve this together. If you got the answer, congratulations, you have come very nice so far. And if you couldn't solve it, at least you tried. And this is a hard question, and we are preparing for the exam. So if you didn't get the answer right, there is no blame for you. No one's gonna blame you. So let's get it started. We want 2x plus 5, right? Okay, what form of x do I want? Okay, right. 1 over 8 x to the power of 2 over 3. So, guys, I have a question. From 2x, can I write it in a form that it becomes 1 over 8x? I can. How? I just write 2 as 16 over 8. So, 2x can be written as 16 over 8x. And if I factorize the 16 from it, I can write it as 16 times 1 over 8x. So I have come so good so far, like plus 5. Okay, let's not forget the plus 5 here. Okay, I have 1 over 8x. Okay, it was very good till here. But what do I do about the power of 2 over 3? Oh, this is horrible. What can I do here? So the thing that you can do here is to make use of the laws of indices again. How? Okay, guys, I know that any number to the power of 1 is itself. Any number to the power of 1 is itself. So I can write, okay, why did the ruler come out? Okay, you can write 16 times 1 over 8x like this. 1 over 8x to the power of 2 over 3 to the power of 3 over 2. So if I multiply these two powers, 2 over 3 and 3 over 2, it's not going to change anything. Why? Because 2 over 3 times 3 over 2 is going to be equal to 1. And we use the laws of indices and the law specifically in which we say that a to the power of m in brackets to the power of n is going to be equal to a to the power of m n. So this is simply equal to 2x. This is 2x. Just it is 2x. So we just change the form. And you're gonna write it as 16. Okay, what is 1 over 8 to the power of 2 over 3? Okay, I can use my calculator. I can say that, okay, 1 over 8. Let's put the brackets. To the power of 3 over 2. No, 2 over 3. 2 over 3. It's going to be equal to 1 over 4. But you can also write 8 as you can also write, okay, let me write it with red. You can write 8 as 2 to the power of 3, and you can write 1 over 8 as 2 to the power of minus 3. And 2 to the power of minus 3 to the power of 2 over 3 is going to be equal to 2 to the power of minus 2, which is 1 over 4. So you can solve it however. You need to know this one. Yes, in the exam, you use your calculator. There are no worries. But you need to know this one. And so, it will be 1 over 4. Wait, let me change to gold. 1 over 4 x to the power of 2 over 3 to the power of 3 over 2. Right? And, guys, something very interesting happened. Now I have x to the power of 2 over 3. Oh no. Oh no. I don't have 1 over 8 anymore. Ah, darn it. Okay, so what can I do here now? Guys, here we need to modify this one. Multiply the whole thing by 2. So 2y is going to be equal to 1 over 4 x to the power of 2 over 3. Now I have 1 over 4 times x to the power of 2 over 3. That's perfect. What is it equal to? 2, it is equal to 2y. So I write it as 16 times 2y to the power of 3 over 2. Perfect. And so, can I just use the laws of indices again? I can. I can write it as 16, 2 to the power of 3 over 2 times y to the power of 3 over 2, um, which you can write as 16 over root index 3 of 4. We do not know about the thirds. So, yeah, you can write it like this. No worries for that one. 16 times 2y to the power of 3 over 2. And you have a plus 5 here, so do not forget it. So if you want to make sure, just you can go back from this one. You can say that y is equal to 1 over 8 x to the power of 2 over 3. And just apply the, you can, apply the index, the exponent, the power, and then multiply by 16, the results multiplied by 16, and then add a 5 to it, and you will see that 2x plus 5, it will be worked out. However, if you have this much time in the exam, I just recommend you to go through the questions and check the answers that you are not sure about. And so our final answer will be this one. Here comes the end of this session, guys. See you till the next session.